Hello, everybody, and welcome to today's session. I'm here to help you out with your exponents today. So, today we're going to learn about exponents and powers, and this is your chapter number 11 in class 7. But obviously, if you want to refresh your concepts of exponents, you can surely join the session and you can watch this video. So, let's begin. Okay, so first thing, what are exponents? Now, you would see that uh, you must have heard about large distances between the planets, right? Galaxies are there, and then we talk about the faraway stars also. Now, those distances are not possible to write manually, like, all the numbers. It is very difficult, isn't it? So, to write them in short form, to write them easily, we have created these exponents and different ways of writing them. All right. So, this was the need of the exponents. Now, what exactly are the exponents? As you can see that this is an exponent number for you, 3 is the base for you, and 2 is the exponent, sometimes also referred as power. And what this means is that this 3 is to be multiplied twice. An exponent tells how many times a number is multiplied by itself. So, how many times you have to multiply 3 by itself. So, here you have to multiply 3 twice. Let's see another example. As you can see, 3 raised to the power 4. It means that it is equal to 3 times 3 times 3 times 3. It is multiplied 4 times. Okay, and it will be read as 3 to the fourth power or 3 raised to power 4. So there are many examples. You can see them and then you can get back also if you have any questions. So let's begin with this chapter and some questions related to this. Now, the first question, find the value of 2 raised to the power 6. Now, how are you going to write it? So 2 raised to the power 6, what they're asking you to do is write down the number in the expanded form. Now, expanded form of this would be 2 times 2 times 2 times 6 times and then multiply them. So what you'll get? 2 2s are 4, 4 2s are 8, 8 2s are 16, 32 times 2, then how much is that? 64, right? Now second, similarly, 9 raised to the power 3 will be 9 3 times. So 1, not 3 times exactly, but you're multiplying it this way. So again, you will multiply. 9 nines are, don't write 18, okay? It is 81, then times 9. Now how much is that? 729. Okay, let's have the next question. 11 raised to the power 2. Again, write down this in expanded form, 121. And if you look at the fourth, it will be 5 raised to the power 4, which is 5 times 5 times 5 times 5. And the answer would be 625. All right, let's move to the next question. Question number 2. Okay, so the first question in this. Okay, so again, now this question is about is the inverse, the reverse of what we have just done now. So here you are given the expanded form. You have to write this in exponential form. So you have to find the base and the exponent. So very easy, super easy. The base is 6. Now how many times is the 6 multiplied? 4 times. Now let's have a look at the second one. Now t here, how many times are we multiplying? 2 times. Third, I'm directly writing the answer here. So we have base as b and it's multiplied 4 times. Fifth one. Now this one is interesting because this doesn't have just one number. There are two numbers. Okay, so you will not panic. You will take them as two different numbers. They are different, so you will consider them different and solve them differently. So 5 raised to the power 2 and the other one is 7 raised to the power 3. Now fifth one is 2 times 2, again a times a. They are different numbers, unique numbers, so you have to write the exponent form for them differently. I mean, you have to separately write their exponent form. Now here, children, there are certain, you can stop your answer here, but there are certain exponent rules. Okay, so you will be learning about them later. So this can also be written like this. Now, why I have done it? Because they have common power. Okay, so because of the common power, we can write them this way. Now the last question, sixth question. So this can be written as 3, you have a power 3 raised to 3 times c is how many times? 1, 2, 3, 4, and then d. Also, those who are familiar with algebra, those who have done algebra, they are already familiar with this. Those who have not done algebra, then here I want to mention something. Children, when you have no sign operation between any a number and a variable or between two variables, then we consider it to be multiplication. This is nothing but multiplication form of these variables, okay, these numbers. So easy, isn't it? Okay, now let's have a look at the third question. Now from here, this is the second level of questions based on exponents, like a little tough, little difficult than the previous one. Here you have to, now these numbers are quite big. So you have to write them in exponential form. For this, what you need to do is first write the product form of these numbers. Now that, how do you write the product form? I want you to go back to the first question. Yeah, even second question would do. Now you can see that in each of these questions, like you have written them the same number and then you know the product of that number, right? So we have to write these number in such a form. And the best way to do it is doing factorization of the numbers. Okay. So what do? We will write the number and we'll do the factorization. So you should, again, you can use the divisibility rules, as you know that the last digit in this is 2. So you can use 2. So divide this by 2. 2 twos are 4, 2 fives are 10, 2 6. Now again, because 6 is even, I'll continue to divide. So 2 ones are 2, 2 twos are 4, 2 eights. Now here 2 6 and 4. Here 2 threes, 2. Then 2 ones are 2, 2 6 are 12, then 2 again, 2 eights, then 2 fours, then 2 2, and 2 1. Now, it is always advisable that next you write the product form, like how many times it is being multiplied. I'm writing the answer here, so you can count them 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times it is. So it is 2 times 2 times 2 times, count them 9 times. Okay, so this will be equal to 2 raised to the power 9. So this was the first one. Okay, let's try the second. Three hundred and 43. Okay, now how will you do this? So for this, okay, there are a few numbers that you that you have to keep in your mind. Like 343, it looks very odd, right? So there is a number 7 which can divide 343. All right. So let's use that. And then will be 9. So here we got 7 3 times. So the answer is this. Now let's try 749. Now 729. Now there is divisibility rule of 3, that if you add all the digits, it should be divisible by 3. So if you add all the digits, you'll get 18, which is divisible by 3. So we will use 3 over here. So 3 twos are 6. Again, it is divisible by 3. Again, 3. Okay, now here it is 8, 1, 2, 3, 4, 5, 6 times 3. So we will write 3 raised to the power 6. Now the last one I'm solving here at the bottom, 3125. So 5. Now again, now this you can write as 5, 5 times. Alright, so this is the answer. Now, next question. Now, in the fourth question, you would see that there is a pattern that the base, like, let's have a look. The base of, like, the base and the exponents, right, of this. Now, here we have reversed them. So, in such cases, there is a property, okay, if, like, these numbers are, the bases, like, these are greater than 1, okay. If I take, like, this is AB and BA, and then these are greater than 1, right? Then the number with the higher power, okay, the number with the higher power will always be greater, okay. So here 3 raised to the power 4 will be greater, okay. Again, I'm repeating, the if in case the base and exponents are being interchanged in the exponents, in the numbers, then the one with the higher power will be the greater number, okay. So in the second one, 3 raised to the power 5 will be greater. Second, third one, 2 raised to the power 8. Third one, fourth one, this. And the last is 2 raised to the power 10. So these are our answers. Keep this property in mind, okay. But the condition is that A and B should be greater than 1. And they both should have the base and exponent same number, but position is different. Now let's move to the fifth question. Express each of the following as product of powers of their prime numbers. Now, again, the question is similar to question number 3 that we have done. Right here, what we have done, that you have calculated the exponential form. For that, writing them in the exponential form, you have find the prime factorization. So we are going to do the question in the similar way. It is also talking about the prime factors. That what happens sometimes, if I take number 64. So 64 can be written as 8 times 8, right? 8 square. So you can write, this is absolutely correct because 8 square is also an exponential form. But then in this question, we have been very specifically asked for the prime factors. Okay. In prime factors, it becomes very important to use the prime factorization only. So you will take the number, and again, use only prime factors. I suggest that start from 0, from 2, okay, 2, 3, 5. Well, it doesn't matter if you want to start with 5. Suppose if you can divide by 5 first, you want to start with 5, that's also okay. All right, but use the prime numbers. So it is 2 threes are. So let's divide it. 8, 1. Now here we reach 3, 27, and then 1. So this we can write as 2 is 3 times, and then 3 is 4 times. Okay, so it is product of the prime numbers and in the exponential form. Let's see the next one, 405. Now the last digit is 5, so we can divide this by 5. Again, it is the table of 3. You will find this number appearing quite a lot of time when you are doing the prime factorization. So 5 times 3 is how many times? 4 times. So you can write it like this. Now 540, 0 is there, so you can either divide by 5 or by 2. Your choice, whichever you find easy. So this is 5 once, then 0 because we cannot divide 4, then it becomes 40. 8, 8 is even, so we'll divide by 2. So this we can write as 5 times 2 raised to the power 2 times 3 raised to the power 3. The last one is 3600. We feel tempted quite a lot for dividing by 10 because there are zeros, but don't, okay? You have to use only the prime numbers. Again, 5. I'm taking 5 because it will reduce our calculation time. If you'll start with 2, then it will still feel longer. It will take a little longer. So this is 5 twice, 2 4 times, and then 3 twice. Okay, so again the calculations and this is how you can calculate. The next question, okay, simplify. Now simplification pretty easy. All you have to do is just expand and solve. Okay, so let's start with the first one. 2 times 10 raised to the power 3. This is again very easy concept. See, there are either you write it like this. Okay, and I hope that you remember this type of shortcut in math where all you do when you have zeros at the end is to count how many zeros are there and directly write. Now you can also look at this like the 10 raised to the power 3, power was 3, and here we have placed 3 zeros at the end. Okay, so you can directly write it as 2000. Now second, this is like this, so again expand them. Okay, so you can calculate them separately. Third is 2 raised to the power 3 times 5. So you know that you can write it as, so 2 twos are 4, 4 twos are 8, 8 fives are 40. Then fourth is, so 12, 48 times 4. The next is, the fifth one is interesting. Should we expand 10 raised to the power 2? No need. Why? Because we are given to 0 here. And any number multiplied by 0 will always give you 0. You do not need to solve any part of it. Now here you will expand 5 times 5 and then 3 times 3 times 3. So this you can again, you can figure out your own way of calculation. You can like multiply 5 and 5 first and 3 threes are 9 and this and then separately multiply them, or you can break it down into parts and then calculate, like you can calculate 5 and 3 15 and then so on, whatever your wish is. You can do 5 5s are 25, 25 threes are 75, 75 times 9 you can write. Then it's easier to calculate when you have one digit number somewhere, right? So this is the sixth part. Now let's move on to the sixth, seventh. 2, 4 and 3. 2 raised the power 4 and 3 raised the power 2. So again expand. Solve about expanding and solving. 4, 8, 16. 16 times 9 is 144. Okay, let's move to the eighth question. Let's see what the question is. 3, 2 and 10, 4. So 3, 2 and 10, 4. Easy. You want to expand, you can write in expanded form. If the question is specifically asking you to write in expanded form first, then you must write. Or you can directly solve it as 9 and then place the 4 zeros from the question. Okay. Now, these are like a little different. Now, again, the concept remains the same. The only difference is that there is a minus sign along with the number. And remember that this minus sign is inside the bracket, okay? It's not outside. So you have to apply the same concept on the sign also. So how we'll write this? So negative 4 times negative 4 times negative 4 times negative 4. Okay. So what you will do, solve the sign first. Okay. So you know this concept, right? That when you multiply same signs, you get positive, and when you multiply different signs, you get negative, right? So multiply them. So let's take, so minus into minus gives you plus, right? Plus into minus, minus, minus into minus, plus again. Or there is a property. Okay, now what is that property? How many times are you multiplying the negative sign? See, here it is 1, 2, 3, 4 times negative, right? Now 4 is even. So if you have, suppose, even number of times, you're multiplying a minus. That becomes positive. And when it is odd number of times that you're multiplying minus, it becomes negative. So here it is even number of times, so it becomes positive. Now just multiply 4 times. And what is the answer of that? That is 256. Now second, so it is minus 3 into negative 2. Now how many times? 3 times. Okay, now count how many negatives you have in this. Again, see everything, there we are multiplying everything. This rule is applied only when you are multiplying them. So we are again multiplying them even number of times. So our answer will be positive and it will be 3 twos are 6, 6 twos are 12, 12 twos are 24. 24 is our answer. Next question, third part is negative 3, 2 and then negative 5 raised the power 2. So we will see, you can write it like this. So solve them. Again, the sign will be positive because in total we have 4 times we are multiplying this minus sign. So now it will become positive. And then you have got 3 times 3 times 5 times 5. The answer is 225. Okay, easy, isn't it? Now let's have a look at the last question. Negative 2 raised the power 3 and negative 10 raised the power 3.
Now, in this question, before you start writing the expanded form, I want you to look at the negative signs and what are the powers. So you see there are power 3 with negative 2 and power 3 again with negative 10. Both the numbers are having negative sign. So in total, how many times are you going to multiply the negative sign? Isn't it 6? Because 3 plus 3, 6 times. Let's confirm our theory. Let's write the expanded form. Negative 2, negative 2, negative 2 one more time, then negative 3, negative 10, negative 10. So you see, you count them, it is 6 times. 6 times is positive. So positive, you know that it's even, I mean. So even means your sign would be positive. So it is positive, so you will leave it. You don't have to write the positive sign again because we know it is understood that if there is no sign, it means it is positive. Just multiply the numbers and you know there's a shortcut. Just multiply 2, 2, 2, you'll get 8. And since there are 3 zeros, so we put 3 zeros. That's the answer. Now, let's have a look at the last question of this exercise. Now, it is also of comparison of the numbers. Compare the following. Now, to compare, see, they have given us the power of 10. Okay. So, you have to look at the power of 10 here, that which one is greater. Hmm? So, obviously, you know, we have to look at that, but then compare 2.7 and 1.5 also this case. In these cases, two questions. Look at the number. We have only one whole number, like one digit before the decimal. Number of digit is also same. The decimal placement is also same. In such cases, you don't have to compare, like, you don't have to worry about the whole number part, okay? Or the part which is being multiplied. You just look at your exponent part. Because 2.7, 1.5, they are like 2.7 is greater than 1.5, but these are negligible in comparison to the exponent part. So what do? We take like 10 raised to the power 12 and 10 raised to the power 8. Okay. So let's write them down. What do you think is greater? Which one is greater? 10 raised to the power 12 is greater than 10 raised to the power 8. So we just directly infer from here that 2.7 times 10 raised to the power 12 is greater than 1.5 times 10 raised to the power 8. Now let's have a look at the second. The 4 and 3 again, you don't have to compare them because there's hardly any difference between them. So you will directly go to your exponent part. Okay. So here 10 raised to the power 14 and 10 raised to the power 17. Which one do you think is greater? So it is 10 raised to the power 17, which is greater than the 10 raised to the power 14 exponent. So if 10 raised to the power 17, now you just write the full thing. If this is greater than 3 times 10 raised to the power 17 will be greater than 10 raised to the power this. Okay, 4 times 10 raised to the power 14. All right. So this was our first exercise. See, I want you all to, I'll meet you tomorrow. Okay, I will put another exercise for you all to watch. Do go through and let me know if you have any doubts. Leave your questions, queries in the chat and I will get back to you. Okay, thank you so much.